Hi, welcome to another video which is about calculating probabilities. And before we proceed to formal definitions and formulas, let us start with some simple examples. So imagine that you have a fair dice. There are 6 faces and there are 6 possible outcomes which are equally probable. So this is what I meant when I said fair dice. So you can get the face with 1, 2, 3, 4, 5 or 6 dots on the face, and we can denote the set of possible outcomes as A. So as I said before, you can get the face with 1, 2, 3, 4, 5 or 6 dots on the face. So sample space is simply a set consisting of all the possible outcomes. Here we are. So imagine that you want to calculate the probability of getting a face with 2 dots on the face after rolling a face dice. So there are 6 possible events. As we mentioned before, you can get 1, 2, 3, 4, 5 or 6, and only one of them is denoted as successful. In our case, this successful event is getting a face with 2 dots on it. And as we mentioned before, all 6 outcomes are equally probable, so probability of getting 2 is equal to 1. Event which is successful, there is only one event considered successful, divided by 6, which is the number of elements in the sample space. Now consider another example. What is the probability of getting the odd number? So there are 3 numbers like this, 1, 3, and 5. There are still 6 possible outcomes in the sample space. So in order to calculate this probability, we need to divide 3, the number of successful events, by 6, the number of elements in the sample space, and you will get 1/2 or 50%. So the probability of getting the odd number after rolling a fair dice is equal to 50%. So based on this, we can define the rule for calculating probability. The probability of success is equal to the number of elements in set S, and this set contains only successful events, divided by number of elements in the sample space. And just to recall it briefly, sample space consists of all the possible outcomes of a certain event. Now, let us consider another example. Imagine that you toss a fair coin. Again, fair coin means that probabilities of getting head and getting tail are the same. So if you toss it one time, then you can get head with 50% probability and tail with 50% probability. Now, imagine that our problem becomes more complicated. If we toss a coin 2 times, then we end up with 4 possible outcomes. So, namely, you can get 2 heads in a row, you can get head in the first round and tail in the second round, you can get tail in the first round and head in the second round, or you can get 2 tails in a row. So there are 4 possible outcomes, and if we are interested in probability associated with getting 2 heads in a row, this probability is equal to 1/4. Again, 4 possible outcomes, only one is considered as successful. Alternatively, you could notice that probability of getting 2 heads in a row, 1/4, is equal to probability of getting head in the first round and getting head in the second round. And here is how we can derive the multiplicative rule. So when 2 events are independent, I will get back to this. The probability of both these events occurring is equal to the product of probabilities associated with occurring of the first and the second event. So, two events are indeed independent. Whether you get head in the second round, when tossing the coin for the second time, does not depend whether you get head or tail in the first round. So that's why in this case we can indeed apply multiplicative rule. However, keep in mind that it works only when two events are independent. And in the next video, we are going to discuss further what does it mean, to be independent and mutually exclusive. So thank you for watching. That's it.